Hello, Algebra 2A. Welcome back to another episode of our lesson notes. Today we're looking at lesson 30, applying transformations to the parabola and determining the minimum or maximum. So our goal today is to use transformations to explain and explore shifts in parabolas. We started introducing parabolas in lesson 27, where we looked at standard form and then finding the vertex using standard form. Today, we are going to look at the vertex form of a parabola, which will show us exactly what the vertex is right in the formula. So we don't have to do the opposite of b over 2a and that extra little work. So we're going to explore patterns of the vertex form and how it relates to the vertex of your parabola when you graph it on the coordinate plane. To get started, we'll do a little warm-up. Number one, the graph of a quadratic function is a U-shaped curve called a blank. That would be a parabola. Number two, the parent function of a quadratic function is, parent function refers to the most basic quadratic function, so that would be y equals x squared. So no extra numbers or anything in that. That would be your parent function. Number three is going to be from lesson 27. So if you have not completed lesson 27 on Delta Math, this will be a review of how to change this equation back into standard form. First, x minus 3 squared means I'm going to take the binomial x minus 3 and multiply it out 2 times. So I will use the process of FOIL and get x squared minus 6x plus 9. Next, we will distribute the 2 to each term in the trinomial. Once we do that, the 2 will make 2x squared minus 12x plus 18, and then I still have that plus 5 at the end there. Lastly, we have like terms here, 18 and 5, so we'll combine those together. And we'll get our final result of 2x squared minus 12x plus 23. Today we're looking at vertex form, and this equation is in vertex form. And these two numbers, the x minus 3, the plus 5 here, are going to be the patterns that we start to look at to find the vertex of our parabola. So we will continue to investigate that here in just a little bit. Lastly, where is the vertex of the graph y equals x squared? And to do this, we're going to use some graphing technology to graph this out quick. I'm using a program called Desmos. If you're in Mr. Rengel's class, there's a link right on the schedule to get to this program. So you're going to get y equals x, and then shift 6 will make a exponent x squared. And the vertex we're looking for is where is the lowest or highest point of the parabola, and there it is. So our vertex of the parent function is going to be 0, 0. So there's our warm-up today, some skills that we will use as we start to investigate transformations of parabolas. So next, we're going to start to investigate shifts. A shift is a vertical or horizontal movement of a function. Today we are investigating quadratic functions. So example 1, we're going to graph y equals x plus 7 squared, determine the vertex and the equation of the axis of symmetry, and explain how the graph shifted relative to the parent function y equals x squared. To do this, we will use some graphing technology to kind of find some patterns that we are going to see when we see these parabolas shift. So I'm going to use my graphing technology of Desmos to start to investigate what's happening when I start to add numbers into my parent function. So I've got the parent function graphed in red, and then I've graphed y equals x plus 7 squared, and then we're going to start to look at the pattern of what's happening to the parabola. How is it shifting? So my parent function is y equals x squared, so no numbers in the equation, and that's going to have a vertex directly at 0, 0. When I graph y equals x plus 7 squared, I've now introduced a number paired with the x inside parentheses, x plus 7, and if we look at our graphing technology, when I put a plus 7 in there, it moved my graph 7 units to the left, and now my vertex is negative 7, 0. So we can see as we start to put a number inside the parentheses, it's going to start to shift my graph left and right. And that's going to be true for our function with quadratics, and then any function, when you start to group numbers with the x, it's going to start to shift your graph left and right. So I can answer the vertex is going to be -7, 0. My axis of symmetry is going to be x equals -7. And then my description would be that this is going to be a left shift of 7 units. Now we can investigate this a little further. If I make this x minus 7, so you can maybe think about what's going to happen if I make this x minus 7, which is the opposite of x plus 7. And we'll start to see that the graph will shift to the right 7 units. So when you're looking at in your grouping, in your parentheses, if it's x plus, it's going to shift to the left. If it's x minus, we start to see our graph shift to the right. So let's go to example 2 and start to investigate this further. My vertex form of a quadratic function is y equals a times x minus h squared, and that x minus h is going to be in parentheses plus k. Your vertex is going to end up being your h value as your x coordinate of your vertex and your k value as your y coordinate of your vertex. And then the axis of symmetry is going to be x is equal to h. So whatever shift left and right, that's going to also be your axis of symmetry. So far we've determined from problem 1 that plus h is going to shift us h units to the left, and minus h is going to shift us h units to the right. So now we're going to determine what does the k value do to our function. We're going to start to see that because now we're introducing a k value. So we're going to head back to our graphing technology and start to look at how does the k value affect my graph. So in Desmos, I've gone ahead and put in the first part of our function x plus 2 squared. And very similar to the problem above, x plus 7, we're going to start to see a shift to the left. So we're going to see a shift to the left 2 units. And there's going to be where my vertex moves, and also my whole parabola is going to shift to the left 2 units. We're also going to introduce then a minus 1. Now, when we put in a minus 1, look what happens to the y-coordinate of your vertex. Your y-coordinate is going to be determined by the k value. So there's going to be a shift of left 2, down 1 to get to my new parabola. So once we've graphed the transformation of the parabola, we can start to gather some statistics. So first we've got the vertex is going to be now at -2, -1. Our axis of symmetry will be x equals -2. That's the green line. That's going to split our parabola into 2 equal parts. And then a verbal description, I could say it's going to go left 2, down 1. And then I just put x equals -2 in green just to match up. That's the green axis of symmetry. So now we're ready to fill in our notes that we started to the right here about what this k value starts to do to our functions. So when a parabola or quadratic function is in vertex form, our plus h shifts us h units left, our minus h is going to shift us h units right, plus k shifts k units up, and then minus k is going to shift us k units down. Now we're ready to start practicing, and we'll go over one problem on delta math just to kind of show how we can start to write these equations in vertex form to represent the transformation of the parabola. So next time you see me, I'll have delta math open to an example problem to help you complete your practice. So taking a look at an example problem, we've got our parent function shown, and the parent function, recall, has a vertex at 0, 0. So what you're going to want to do is you're going to find out where is my vertex now located. So now my vertex is at -4, +2. So recalling that the notes that we just took with the vertex form, this would be a shift of left 4 and up 2. Now when I shift left 4, that's going to be represented with an x plus 4. And when I shift up 2, that's going to be represented with an x plus 2. Excuse me, just a plus 2. And you will see in our interactive assignment that as you start to shift your parabola, it will move to the correct location. Once you get your vertex lined up with your equation, you can hit submit. So there would be our result. And then there's going to be a little interactive guide showing us what we just completed. So you're now ready for practice on lesson 30, day 1, and we'll see you tomorrow for lesson 30, day 2. We'll see you next time.